Okay, everyone. I just wanted to point out in part one, when I did the calculation for the sample size and I put everything, my calculator was acting up. So I brought the good calculator. So the number when I calculated, I don't know what I gave you, something in the 400. No, it's supposed to, when you put everything in the calculator, the answer is 600.25. And as we said, we always, when we do estimating sample size, we round up. So your sample would be 601. So I'm going to go back to the question. Also for the true false question 3, there are four questions true false. Answer would be false, true, true, false. If you have anything regarding that, let me know. So we stopped at finding the confidence interval. In the D question of question 4, if you took a sample of 40 random samples and constructed 40 interval exactly like the one in part, how many of them would you expect to have contain or to contain the true proportion? When you see this question of how many containing true proportion, so they do this 40 times, how many containing true proportion? You say these 40, since we're doing it at 95% confidence interval, it would be 40 times 95, 38 of them, of this sample of 40, will contain the true proportion. So if they tell you sample of 100, how many you expect to have the true proportion? Since we're doing this confidence at 95, it would be 100 times 95, 95 of them will contain. Now, using the results from C, let me remind you what the results was. We did the calculation, and it was the confidence interval 71887611 or 12. Keep this in mind. Now, I'm going to refer to this many times today, how to do hypothesis. It's a major idea for the final exam. So, this is what we got from doing part C. The question, would you reject a null hypothesis that the true rate is 75? Why or why not? So, they want hypothesis, true rate is 75%. H0, HA, and listen carefully. When you're trying to do rate, also proportion, you have P and P. They say, is it 75? So this would always be equal. Here, you'll have not equal 75. If they say, we're going to do a hypothesis to see if there is an increase. If they say increase, then H0 is still the same, but HA would be more than 75. If they say they want to do a hypothesis of a decrease, then H0 always equal, HA would be, in this case, less. But here they don't say increase or decrease, you're testing hypothesis of equal, not equal. So, would you reject or not? Now, you go back because you're going to base your answer on this. Your confidence interval 71, 76. Is 75 possible? Is 75 between 71 and 76? Yes. So, it could equal 75. So, are we going to reject H0? No, we're not going to reject. But if they say, could it equal, say, 77? Yeah, it's not going to be 77, so you say no to this, so in this case you would reject H0. So this is what you need to know for question 4. Question 5. So I want you to read it first to be familiar with the concept. So the semiconductor manufacturer produces controllers used in automobile engine. Customer requires the process fell out of fraction defective not to exceed 5%. So the defective rate should be less. So percentage of defect must be less than 10%, or that's what they're hoping for. And the process capability at alpha, so they want to use alpha of 5% or 0.5. They're going to test this on a sample of, they tested this on a sample of 200, and 4 of them found to be, they found 4 of the 200 defected. So, question A. Question A, what's the parameter of interest? Parameter would be the only thing that's changing in this question, and that would be the percentage. So, you just say the percentage of defect. That's your parameter in the question. Now we're going to test the hypothesis. Now remember what I said earlier. When you do the hypothesis, you have the null hypothesis, the alternative. It's proportion, we say P. So you say, they're hoping to have a P of, so this is less than 5%. I read it wrong. So this is less than 5%. So P, this would always be equal to whatever the percentage is, and this would be consistent with the question. This time, it's less. The previous question was not equal. This one is obviously less. Less would be a one-tail problem, and we call this left tail. Greater than would be a two-tail system, a one-tail system, but right tail. Not equal, that's the only time that it's two-tail. They want you to find the test statistics. For this type of question, when it's hypothesis, so this is the key word, hypothesis, and you know that you have proportion. The test is you take p hat minus the p square root p 1 minus p over n. Okay, well, we need to know a few things. What is p hat? There are 4 defected. You get this p hat from the test. There are 4 out of 200. 4 out of 200, that's O2. Now we put everything, remember alpha being 5%. So your z-test. P hat is O2, P is 5%. This is 5%, 1 minus 5%, and the sample in the question, the 200 people they asked. So I'm going to do this in the calculator. So you have O2 minus O5 square root O5 1 minus 2 over 200. Answer is minus 195. So your test statistics in this case would be minus 195. Question is, find the p-value. How do you find the p-value in this case? Now, p-value z. And I want you to remember this. If you write it down, that's even better because we might see it in a different question. There are 4 cases. Case 1. If your HA more, then your p-value would be 1 minus table. Case 2, if HA less, your p-value is just a table. Case 3, if HA not equal and z-test negative, then your p-value is 2 times table. Case 4, if HA not equal and z-test positive, then your p-value 2 1 minus table. So I'm gonna go to this. Remember, HA was P less than 0.5. So we have P less, that's case number 2. So your p-value is just a table. So you go to your z table and you see what minus 195 is from the table. So I'm gonna go to the table here, a z table. And minus 195 is 0.256. So your p-value is about 2.56%. So I go back to the question. So we found the p-value. Are there any conditions satisfied here? Well, again, conditions, they never change for this type of problems for proportion. You've seen them in 2 questions already, the success failure. So you go NP and N1 minus P. That's 200 times 5%. That's 200, 1 minus 5%. This gives you 10, 190. Yeah, at least 10, then yes, condition is satisfied. Now, what's your conclusion in this case? Now, conclusion for hypothesis. For any problem, you look at your p-value and you see if it's less than alpha. If it is, then you reject H0 and you conclude HA. If p-value more than alpha, in this case you do not reject H0, you do not conclude HA. Remember alpha? It was 5%. So p-value, we found it to be 0.256. That's less than alpha 5%. So we're less than alpha, so we're going to reject H0. We're going to conclude HA, and remember, HA, we have enough evidence to show that P is less than 5%, because that's what HA was. Now, I'm gonna stop this video, so we still have question 6 to do, so I'm gonna stop it now, come back to and do question 6.